me introduce our final speaker, and coming again from another perspective of a global aerospace and defense manufacturer perspective, Howard Mason. Howard's responsible for information standards and engineering business solutions in the office of the CIO at BAE Systems. He also leads the ISO activities on industrial data as chairman of the ISO Technical Committee 184 of SC4. And he also, as his third or fourth or fifth job, serves as heritage manager for BAE Systems in the UK, responsibilities for corporate archives at Farnborough and management of the heritage product and project activities. So join me in welcoming Howard Mason.
Thanks, Don. That's a good introduction. And the other two presentations have really highlighted the business need that we have for standards. But to explore why we need standards, I'm going to use my heritage manager role a little bit and trace back through the business requirements that led to the need. As a company, we have a long and complex history of amalgamations. In fact, this picture's not to scale. We can actually trace our first component back to the year 1560 with the Royal Gunpowder Works. So we've been doing cool engineering for 450 years or so. But I'm only going to go back to the early 1970s when one of the major university projects that was in hand was developing the first stages of computer-aided design for the shaped surfaces of aircraft. Each company had their own team of mathematicians and their own proprietary surface format. But as we started to build aircraft like Concorde and Tornado, there came the requirement to exchange that information between companies. And as long ago as 1976, the European aerospace industry collaborated to reach the milestone of exchanging simple surface data. That's before a lot of you were born. If we go forward to the later 1970s, computer-aided drafting came in with the teams of gurus in the design offices on 3 or 4 dedicated terminals producing the first electronic drawings. Again, innovation was at the forefront with many different computer-aided drafting systems around. And just as we used to do with drawings, that information was lovingly carried down to our numerical control specialists in order to have it re-entered, recalculated, so that we could manufacture components. People then started to see the problem. Not only working within collaborative projects, but also within your own organization. You needed to be able to move electronic information from point to point. And we started to get some initial neutral exchange specifications to facilitate that. And they were gradually extended to support the then needs of aerospace and of the automotive industry. As we moved into the 1980s, we started to build a backbone of this digital information, and more sophisticated tools came from the vendors. And more people got these flickering green screens on their desks for computer-aided design. And we started to build some links where that data could be transferred through to production. We also started to see global supply chains emerging and recognized the value of being able to exchange data globally, which led to the launch of the development of an international standard in 1984. Sadly, I was there at that first meeting, so I don't know whether that makes me part of the solution or part of the problem. We grossly underestimated the effort that would be required to make that happen. The first estimate said it would take 2 years to write such a standard. It actually took nearer 10, because we recognized the growing business need to be able to support different functions within the business. Meanwhile, the CAD tools were getting quite widespread, and the newfangled product structure, product data management, started to come in. And just as the original surface design systems were in place, we now had proprietary systems there as well, and the same sort of interchange problems. As we moved into the 1990s, that information came together. Nearly everybody who was involved in design was designing electronically, which was great for the metal parts. And then came along composites. How are we going to support those? How are we going to manufacture them? The data that was being produced in design started to flow through to the manufacturing side on a regular basis. And because of the growing costs of projects and the multinational nature, this information exchange wasn't just a luxury, it was essential to do business. And in the early 1990s, we started using the STEP standard that had now been approved through ISO for moving drafting, 3D geometry, and product structures between partner companies. On the Eurofighter program, which some of you will be familiar with, production is shared between 4 countries. We make the noses and tails, Germany makes the fuselages, Italy makes some of the wings, Spain makes some of the wings. Each of those countries are then responsible for the whole of the aircraft. So we had a massive data interchange and synchronization problem, which was solved by moving the data into a standard format and shifting it between the different systems in the different companies. The unexpected benefit that we got in there was that by translating the data into a neutral form, we filtered out poor quality data before it was disseminated to the other partners. And that saved literally thousands of design changes being propagated throughout the fleet. That was an entirely unexpected benefit. Moving now into this century, we've got design split across suppliers as well as our partners. We've got much more sophisticated sets of information being held within our design tools, product manufacturing information, the sorts of material data that you're going to need for your 3D printing, all embedded within the base systems. You've got the sort of integrated analysis that was referenced yesterday as a requirement, be it for stress analysis, the fluid dynamics, or the thermal analysis of the product. The other big business driver was that we'd been too successful in making our products. They were lasting far too long. Typical life of an aircraft now will be 30, 40 years or longer. So there's actually a problem in getting revenue from manufacture. Companies are moving into the full support area, the right-hand side of the smile, as we saw many times yesterday, the increasing focus on through-life support. And typically, the standard components that Jordan illustrated so graphically in the basement of his shop in California, those standard parts used to come in a paper catalogue. Now they're coming in electronic catalogues. How do companies use those? So again, we had to take the basic standards and extend them to support products throughout the entire life cycle. We had to build standards that supported the multiple views required by industry, and to track all the information that was required to support a product through life. As Manuel says, that's a tremendous opportunity for the automotive industry. We have that issue too for aircraft and ships and submarines and other of our products. And that really needs to pull in information from multiple different standards. The electronic libraries from standard parts can also be standardized so they're electronically available. Actually, the standards organizations are using that for the components that you need in manufacturing systems. There's a common library in the IEC of the components that you need. So how are we using that? Well, if you think a car is complicated, just go look at an aircraft carrier. 40-year life and millions of components, all of which have to be tracked. And I show this picture because on Friday, this is going to be put to the test, because the first new British aircraft carrier in 30 years will be launched at Rosyth in Scotland. Completely computer-aided designed, and with a toolkit now for maintaining its information through life. And that gets to be quite interesting, because it's not just our Royal Navy that's maintaining that data. It's a shared responsibility with the industrial consortium that built the carrier. So the industry requirements that we have coming up to today's date is to support the product throughout its entire life cycle, to track data for every instance of a product and link it back to the design configuration. Now, as I mentioned, our products last 30, 40 years. Although with Dassault Systems I did see their CATI prototype of CATIA in 1979, that's still shorter than the product life cycles that we've seen. And it's a real challenge to be able to preserve your data independent of any system, so that you've got the freedom to move to the latest technology. We're also seeing recognition from the customers that standards-based solutions provide a real business benefit. I think at the last count, our company made 1,200 different products for the British Armed Services. They don't want to have a different support system for each one. As this information becomes more ubiquitous, we also need to support the requirement for others to consume it downstream. Not everybody has a CAD system. Most people have a browser. So we've had a growing requirement to support 3D visualization based on these standardized models. And the standards for that are now being produced. And what we're seeing as a demand is to bring together all the information standards that we need, implement them using the new technologies, and be able to preserve data long term. We have a lovely example of that, actually. How many of you flew to get here? Quick show of hands. Okay. In order for your aircraft to be safe, they need to maintain the data about that aircraft throughout its life. Therefore, they've got to maintain the design data through its life, 30 years or so. So what do? We put it on a CAD system, which has probably got a design life of 10 years, which is running on a computer operating system which changes every 6 months or so, running on hardware which has been delivered and is therefore also obsolete. That's the way we keep our data safe. Enjoy your flight home. In summary, the requirements for industrial information have grown dramatically and will continue to grow, and that's a key message. The standardization work that's been done is not yet complete. If we look at industrial information, there's another way to categorize it. Across the middle of the screen, you'll see the product life cycle, and going backwards, another dimension, the flow of information between different functions. And you'll also think about the flow of information from the suppliers to a company to their end customer, wherever they sit in the supply network. Underpinning that, the IT systems in each of those areas is going to change on a much more regular basis than the products. So where do standards fit in? Oh, I mentioned the S word. They're there to help support interoperability across the industries, across the whole supply network, and throughout the life cycle, and really to save you the costs that come in from maintaining point-to-point solutions. US Department of Defense quote about $150,000 or $175,000 for each point-to-point solution that they have. If you can eliminate that, then that's a direct saving to your industry. And those changes come in if your company reorganizes or you change your software or hardware environment. But standards have to be ready on time. for your use. There's no point in them lagging years behind, and that requires some careful planning. One of the sets of standards that I'm responsible for in the SC4 environment is a suite of different application protocols, different views of standardization throughout the life cycle. And these aren't promises, these are all available standards that are in production now, apart from AP 242, which is not going to be published for about 2 more weeks, but that's based on some previous activities. So the capabilities are there. And really, if you look at the sorts of environments in which you need to exchange data, we can put together those underlying standards, different views to support your individual requirements, and then look at the information you might need for ordering your spare parts, which is a series of product characteristics. The 5-digit numbers, by the way, are the ISO standard references. Those product characteristics are what you use to build up your product libraries and classification schemes, of which there are probably an infinite number, and are supported by an open technical dictionary. And finally, you can simplify that information for consumption through visualization. And we've recently added a new standard on data quality, which underpins all this information and gives you some assurance of what you can use. So where are we going next? I was quite pleased that many of the items that we've highlighted here in terms of our future work programme have been highlighted as the needs today, needs of this workshop. We have a need to pull together data through life, the different forms of analysis. We need to support the explosion of data that you get when you start to support individual products and the additional product manufacturing information. We need to look at new deployment technologies and link to the transactional standards, the buying and making activity. And of course, we already heard about the Internet of Things, which is going to deliver us more data than we've ever thought about, and will actually make the human race bit players on the internet because the devices will be creating much more content. And throughout all this, we have to protect the investment that your companies make in generating information. That's absolutely critical. Our company produces a couple of $1 billion worth of raw engineering data a year. If we bought a company for that much, we'd at least put some guard on it. So as a company, what we're doing is to encourage our businesses to look at their information requirements and to try and solve the solution, very much like the triple helix. We're working with the standards bodies directly to make sure we have the standards that we need. We're working with the vendors to ensure that they implement them, and working with trade associations and consortia such as PDES Inc. to make sure that we have implementations that are tested and can work. And we can use the trade associations to roll out these solutions to the small and medium enterprises. In fact, very quickly, the US aerospace industry and the European one that uses the same process has tried to define the necessary and sufficient conditions it needs for interoperability, the stuff in the middle row. That model is put together by the standards bodies to show all the pieces you need to ensure interoperability, working from the business scenarios at the top, the processes and data, the underlying IT, and all the other pieces like the contractual environment, the security environment, and all the assembly tools to build a proper solution. In simple terms, if you know what you want to do as a business, the challenge is to take that scenario, break it down into standardized components for processes, for data, for security, and so on, with the underlying IT services, and with your trade association or with the standards body, pull together the requirements for designing a solution, implementing it, and operating it. And that provides a clear set of guidance for the small and medium enterprise. In both the European and US aerospace industries, we are now publishing this on our websites so that industry can use it. And people often joke the great thing about standards is there's so many to choose from. Well, actually, what we're doing is making the choices, and this is an ASD selection for the standards required to support different classes of business scenario. So there's a systematic industrial process there for meeting the needs of industry collaboratively. So what are the key messages? We all need interoperability. It's a right. It's not a privilege from your vendor. You need to have your data that is independent. Changing industry requirements means that as part of policy, we need to continue to invest in standards. But they're only of use if we have effective IT tools, which means that the vendors and the end users need to get together through triple helixes or PDES Inc. or other organizations to support the standards bodies to make that happen. And at a sectoral level, we can drive down costs by making that level of agreement. But the only way that we are going to be successful is to work together, because standards aren't set by somebody else. They're set by you as industry. And together we must take the lead to set that standardization agenda. Thank you very much.
Thank you, Howard. That was a very interesting perspective. I think you can see the benefit of the different viewpoints that we have here, and the ability to the opportunity to satisfy these problems and challenges through further development and deployment of international standards and working together between industry, universities, and government entities.